Is on joint genetic analysis of Holstein Friesian cows performing in sub-Saharan Africa. There are several challenges facing genetic improvement in sub-Saharan Africa. The first is the sparse availability of data and recording systems in different countries. Very few countries at the moment perform routine genetic evaluations. Currently, there are no joint genetic evaluations across country. The question is, how will joint genetic evaluation be feasible and useful in sub-Saharan Africa? In other words, if countries in Africa bring resources together in terms of their pedigree and production data, will that improve African dairy genetic gain or future breeding strategies? Now, the objective of doing this research was to assess and evaluate the availability of common sires being used within and across country, and to test the feasibility of joint genetic analysis between countries in sub-Saharan Africa. Production, reproduction, and pedigree data were obtained from South Africa and Kenya, specifically for the Holstein Friesian breed. The average herd size in Kenya was 144 cows per herd, and for South Africa, it was 99 cows per herd. For the editing of the data set, we ensured that cows between parity 1 to 5 were included. Outliers and missing records were also excluded. To analyze genetic parameters, an animal model was used in which cows with 5 or more herd year season combinations were included. A minimum of 10 cows and sires born or calving per year were also used. However, for the joint genetic evaluation, country was fitted as fixed effect. This is the data structure following edit for within country Kenya and South Africa. We can see that the number of records in South Africa is much higher than in Kenya. And also the milk yield was higher in South Africa than in Kenya. So was the average age at first calving, and the calving interval was much lower in South Africa than in Kenya. I just talked about the challenges facing genetic improvement in Africa, and in terms of poor data recording, and also the objective of the fact that we're trying to find out if there were sires that were common between the countries. For this data, I had the same issues. I had a starting count of over 2,000 in Kenya and about 6,300 in South Africa. For me to do the joint genetic evaluations, I needed standard international IDs, and some of these sires were lacking in that. Also, some sires had missing dates of birth, and some of them had missing herd book numbers. Within the countries for the sires, they were just recorded using arbitrary numbers. We didn't link even within the countries and also across countries. For the production data, I had missing records in terms of test day yields. Cows had missing lactation or parity numbers, missing dates of birth, missing calving or lactation dates. I just showed a slide about the, pertaining the starting count of the sires. If we see the number of sires is much lower compared to what I showed previously. These were the sires that I was able to find adequate information for. But it was quite interesting to see that there were 192 sires that were common to these countries using international IDs, which were mainly from the USA and from Canada. But there were about 85 of these sires used for pure and local breeding in Kenya, and 1,526 used for similar purpose in South Africa. This graph shows the phenotypic trend in milk yield within Kenya and South Africa. And this graph is in agreement with previous studies that have been shown within the countries. There has been no positive trend or improvement in the milk yield across calving years, even though it seems like South Africa seems to have a higher trend than Kenya. This table shows the estimates of genetic parameters within country and across country. I'm not able to show the genetic correlations for across the country, but obviously from the results of the joint genetic evaluations, we can see that there is benefit in combining data, which is evident by the high genetic estimates, depending on the trait, as compared to within country analysis. This again, the analysis, the results from the within country analysis is in agreement with previous studies that have been shown in Kenya and South Africa. This graph shows the genetic trend for milk yield in the sires. Obviously, from the phenotypic trend and this is a follow-up from that phenotypic trend. Obviously, we can see that there has been no genetic progress over the years within the countries. I went on to look at the reliabilities of the 192 sires that were within and across the country. This graph shows that for Kenya and that for South Africa. We can see that Kenya is benefiting from the joint genetic evaluation than within country compared to South Africa. That means that Kenya has the benefit of selecting from a wide population of sires with progeny than within country. Therefore, in conclusion, we have shown that there are both local and international sires that are being used within country, and therefore there is need for proper recording in order to allow joint genetic analysis in terms of sires need to have proper or adequate international identities or herd book numbers. Also, from the graph, we've seen that the sire reliability for milk yield varied within and across country. And again, joint genetic evaluations are feasible and have the potential, especially where there are insufficient data from individual countries. I would like to thank the named persons on this slide for helping me with ideas regarding my data, and also to the International Strategic Fund for funding the project, and to EAAP for giving me the opportunity to present this paper, and to our collaborators. Thank you for listening.
Thank you very much. Any questions? There's one here.
Thank you, Mr. Chairman. I'm Mohammed from Cameroon, and I want to start by thanking Yinka for identifying a small problem in the sub-Saharan Africa and for the brilliant presentation. But my problem will go back to the topic. Yes, from the topic, she's talking about joint genetic analysis of Holstein Friesian dairy in sub-Saharan Africa. But in her brilliant presentation, we have only two countries. So I wish to know, does those two countries can reflect the actual trend of joint genetic analysis in so many countries that we have in sub-Saharan Africa?
This was where we got data from, where we're able to get data. Also, I have data from Zimbabwe, which we're still adding. We actually tried getting data from other countries like Ethiopia and Rwanda, but we're not able to. But at the same time, if we are able, obviously there has been no joint genetic evaluation that has been done. If we are able to do this, obviously it's an African environment, this will be able to inform us on other countries that have not given us data. However, data recording has to be in place for joint genetic evaluations.
There's a question here in the front.
Yinka Abejide. Just one question regarding the heritabilities. You've shown that in Kenya the heritability for milk yield is only 0.3, if I understand correctly?
Yes.
Isn't it a bit strange that this heritability is so low and actually it's actually even lower for calving interval? What's your explanation about that?
The heritability was lower, which is dependent on different factors. Possibly the estimated breeding values for these cows was obviously lower than the within country for South Africa and in the joint ones, and also the herd size will have an effect on that, and the type of size that they're using will have an effect on that. So that has had an effect on the heritability values compared to South Africa. And then apart from that, South Africa has a better breeding program than Kenya. That's why we're seeing that the heritability is quite higher than Kenya.
Okay, so I've been told there's a cable failure, so they would like to change something. I think they can do that now. So Peter can ask a question while they start to do that.
This is a very nice presentation about benefits in two countries, but I was just a little bit skeptical. Is the benefit mostly to Kenya in this particular case, or was there also a substantial benefit to South Africa from joining data in this sense? My idea is that when you try to join data from different sources, it is more successful if both partners or all partners can benefit from it, so that the encouragement is spread to all partners. But was that the case here?
Well, we didn't. When I was in the analysis, I didn't have any bias or expect one to be better than the other, but that was what the results was giving us. And apart from that, I think obviously this is going to be beneficial to countries who have a less adequate breeding program. South Africa has a much more better breeding program because they're a member of Interpol. So, and again, they also kind of, other countries, especially I know Kenya, have started to buy germplasm from South Africa. So if other countries, which likely like this, I'm sure that if I have to do joint genetic evaluations for another country that has similar thing like Kenya, I would, if I get a heritability like this, I would not be surprised. But if we're able to do this and do more joint evaluations, that means there will be a wider population of germplasm for other countries to select from. So that will help to improve breeding program and inform farmers within those countries who have not. But it's a good idea that there should be joint genetic evaluation, because at the moment it seems like South Africa has a better program than others.
Thank you. Okay, thank you very much.